So hello everyone, John here. Well, in this video I would like to share with you the law of sines. Basically there are two useful laws in trigonometry, the law of sines and the law of cosines. And these two laws, you can use them to do many useful things in trigonometry. Now, the law of sines, basically the gist of the law of sines is like this. I don't know why. Let me add a new layer here. And so the law of sines, not the law of sins, but the law of sines. So the law of sines is basically all about the triangle like this. Let's say you have a triangle like this, and the triangle is basically like this. And well, this is, for instance, this is A, B, and C. So if you want to label the sides, then you would say this is side A, small a, this is side B, and this is side C. This is small a, and this is capital, I'm sorry, this is small c, this is capital C. The law of sines basically says that in this triangle, or in any other triangle for that matter, it doesn't matter what the triangle is, it could even be a right triangle or whatever, it basically says that sine A, or no, I'm sorry, it says that sine A by side A, so the sine of this angle divided by the opposite side, this ratio is equal to sine B, so the sine of this angle divided by this side in the opposite side, and this ratio is also equal to sine C divided by the opposite side, which is C. And so using this formula you can calculate whatever you have. For example, if you had the measure of these two angles, and if you had the measure of this side, then you could calculate A, or then it depends on your situation, of course. Now let's see how we can derive this this formula. You could basically, if I had a perpendicular to this side, let's say this is a perpendicular to this side and this is 90 degrees, and if I call this H, so this whole side is B, right? Now you could calculate sine A here. So the proof of this is basically, if I had if I want to calculate sine A in this triangle, in triangle AB, in the left triangle, sine A would be equal to basically opposite by the hypotenuse, which is H divided by this side, which is C. So so this gives then C is equal to, or H is equal to C sine A, right? And then you could also calculate sine C in this triangle. Sine C is equal to H divided by A. So then here H is equal to A sine C, right? So if I call this 1, if I call this 2, then 1 and 2 gives H is equal to C sine A, which is equal to A sine C. And then according to this, you can basically deduce that according to this, you can basically deduce that sine A divided by if I divide everything here, let's say if I write C sine A is equal to A sine C, if I divide everything by A, I will get C sine A divided by A is equal to A sine C divided by A. And then you would get C sine A divided by A is equal to sine C, right? Because these two would cancel out. So now if I divide both sides of this equation by C, I would get C sine A divided by CA is equal to sine C divided by C, and then these two would cancel out, and then you would have sine A divided by A is equal to sine C divided by C. So this is basically capital C and this is small c. So now this, if you pay attention to this relationship, you can see that this is the first part. I mean, this part and this part of our original relationship. Now you can have the same triangle. Let me now if I had the same triangle, of course I need to go back a few steps, and I would need something that now I need to go one more step back. So if I had this triangle over here, and now if I dropped a perpendicular from vertex A in this time, so if this is A, I'm sorry, if this is if this is, let's say this is A, this is B, this is C. Now this time I want to drop a perpendicular from this vertex. So if I did that, I would basically have something like this. So I drop the perpendicular, something like, let's say this is the perpendicular, and this is 90 degrees. So then I would have, here I have A, so this is C, and this is B. And this would be then K, for example. If this is K, then in this case, I would have, you can calculate sine C here and sine B and do the same thing, and you would get something again like this. So let's start with sine B. Sine B is equal to basically K divided by C. So basically K is equal to C sine B. And now sine C here is equal to K divided by B. So K would be equal to B sine C, right? Now, so if I call this equation number 1, call this equation number 2, then 1 and 2 give K is equal to C sine B is equal to B sine C. So again, you got the same thing. Now this basically means that C sine B is equal to B sine C, and divide everything by C. Divide by C, you get so C sine B by C is equal to B sine C by C. These two would cancel out, and you would get sine B is equal to B sine C by C. Now if you divide everything by B, you would get so sine B divided by B is equal to B sine C divided by BC. These two would cancel out, and so then you would get sine B divided by B is equal to sine C divided by C. So now there you have it. This is my first equation. And this is the second equation. So then you can see that sine C by C is equal to sine B by B, and here sine C by C is equal to sine A by A. So it means that everything that you see here is basically equal.